Hello, my name is Armin Wedel and I'm from the Fraunhofer Institute of Applied Polymer Research in Potsdam. I will speak today about printing technologies of quantum dots for future technologies in displays. At first, I would like to thank my co-authors for this great work. What do you need for quantum dot display? At first, you need materials. These materials are characterized by their emitting properties. From these materials, we build up devices, electroluminescence devices and photoluminescence devices. And as a third, we want to print these materials with different kind of printing technologies. Inkjet is very well known, but electrohydrodynamic printing is a very new technology in this field. We do it on our pilot line and we printed quantum dot displays as demonstrators. We have a wide range of research topics at Fraunhofer IAP, starting from the synthesis of the materials acting in quantum dot LEDs, in OLEDs, but also in organic photovoltaics and perovskites. We're starting with the synthesis, the device design and device application, and of course, we're looking for future applications of that. We are working since more than 25 years about the technologies of organic light emitting diodes, starting our first OLED in 1994 and starting our activities on organic electronic and all in 1999. Over the first passive matrix displays in 2001, we are going over to the development of new emitting materials for quantum dots, especially indium phosphide quantum dot materials. We built up our first QD LED in 2010, and we use the high precision EHD printing since 2020. What is so important and why we want to use electrohydrodynamic jetting and how does it work? In contrast to inkjet, we use a needle and a small nozzle which are connected to a high voltage. If the high voltage is on, the fluid inside the nozzle come out by the force of the electric field. The distance between the needle and the substrate is very small. So we have to take care about that if it's a good printing facility. Now I want to come to the comparison between pattern QD matrix systems by inkjet and EHD-Jet. The inkjet system or the inkjet printing is limited. We can only reach a minimum of 40 micrometers, and for picoliter droplets are too large for printed in so small pixel defining layer. With the EHD-Jet of a volume of 0.5 picoliters, the drops fits fine in the pixel defining layer, as you see on the middle and in the right picture. So we can say this with EHD-Jet printing, 1 to 10 micrometer pixels are possible. We could realize 50 micrometers reproducible. One example for that, for the EHD printing, is the quantum dot color filter for micro LED displays. And here you could see that we could print blue and green quantum dot materials on a 15 or in a 15 micrometer pitch, so that we can realize resolutions up to 1000 ppi or later also 2000 ppi. That we do together in cooperation projects, one related to Korea and the other one is related to a European project, High Accuracy. The electroluminescence properties of quantum dots we use in QD LED devices like an OLED device. And here we could inkjet printing. As you can see here, we could successfully demonstrate the 3 colors of RGB for printing on the same substrate. The color saturation is very good and shows no other color contaminations. Of course, we have to work for the blue devices for further optimization. It's a project which we do together in a German-Korea cooperation in the project of the name of FIPAC. I hope I could show you that we have interesting projects of inkjet and EHD-Jet printing. We make it together with partners worldwide. And now I would like to say thank you very much for your attention.